We found that particles are a disturbance of a field which propagate with an energy and a momentum obeying the relation. This is Einstein's relationship between energy and momentum for a particle of mass m. However, in quantum field theory, the mass is not related to the kinetic energy, but to the quadratic term of the potential energy. The energy is related to the time frequency of the vibration of the field, while the momentum is related to its spatial frequency. We see that this interpretation of the nature of a particle as a disturbance of a field naturally accounts for the wave-particle duality we have in quantum mechanics. If a particle like the electron is in fact a disturbance of an electronic field which extends everywhere in the universe, we therefore understand why we have identical particles, why all the electrons of the universe are in fact identical particles and cannot be distinguished from each other, because they are all excitation of the same field, which is universal. The field phi transforms as a Lorentz scalar under Lorentz transformation, which are either boosts or rotations. In particular, this means that the field transforms as a scalar under rotation in the Euclidean space. Remember that the spin is an intrinsic angular momentum, which is a property of the particle, and we know that an angular momentum is also a generator of the rotations. We also know that only objects with spin 0 transform as scalar under rotation. Therefore, we conclude that the particles associated with a disturbance of a scalar field have a spin 0. Let me now finish with some jargon. When the disturbance of the field is such that k squared is equal to m squared, or equivalently E squared equal P squared plus M squared, we say that the momentum k is on mass shell. And when k squared is not equal to M squared, then it is out of mass shell. A disturbance of the field which is on mass shell is sometimes also called a real particle. And when it is out of mass shell, it is called a virtual particle. The words real and virtual are not really appropriate, because there is absolutely nothing virtual in a disturbance of the field which is out of mass shell. It is just that because it is out of mass shell, the propagator will be close to 0, and therefore this disturbance will not propagate very far. And in other words, the particle or the disturbance of the field disappears very quickly. This is unlike the case of a real particle, which corresponds to a disturbance of the field which is on mass shell, corresponding to the resonance of the propagator, and therefore will be able to propagate infinitely. So from now on we will try to avoid the terms real particle and virtual particle, and instead we will refer to being on mass shell or out of mass shell.